Hi everyone, in this video we're going to finish up the two identities that we haven't done yet. And so the first one is this one. Solve the tangent of x is equal to 3 sine of x for all solutions within 0 to 2 pi, which is our usual range. Okay, and so in section 7.1, this is all about solving trig equations using identities. And so probably what we want to do is rewrite tangent in terms of sine and cosine. So I think that's going to be a good first step for us. So that's what I'm going to do here. So I could rewrite this equation as the sine of x divided by the cosine of x is equal to 3 sine of x. Okay, so that's a good start. And then we can rewrite, so instead of having a quotient on the left-hand side, we can multiply both sides by cosine to get that the sine of x is equal to 3 times sine times cosine. And now we're left with this thing over here on the right, and the urge may be to divide both sides by sine, in which sine would seemingly go away, and you'd have 3 times cosine is equal to 1, cosine is equal to a third, so on and so forth. But that's actually not what we want to do here. And so there's a mathematical reason why we wouldn't want to do that, and I won't go into that. But so what we're going to do is instead I want to bring sine over to the right-hand side, or I guess everything else over to the left-hand side. I want to get an equation in the form of something equals 0. And so let's do that. So I'm going to come over here. Oh, sorry. I'm going to come over here. And I'm going to rewrite this as the sine of x minus 3 times sine times cosine equals 0. Okay, so I brought the right-hand side over to the left-hand side. And so now I have something equals 0. Sine is common to both terms, so I could pull sine out. So I have the sine of x multiplied by 1 minus 3 cosine of x, because sine was common to both. And now we have our situation which we were dealing with mostly in class, which is something times something equals 0. So either the first thing is equal to 0 or the second thing is equal to 0. And so that's what we're going to go with. Okay. And so when is sine equal to 0? Again, you can draw a picture of sine, and sine looks something like that. 0 pi over 2 pi, so on and so forth. And so you can find that for that one, so the case when sine of x is equal to 0, I know that x is either going to be 0 or pi. Okay, so we went over that. I think that was our very first identity in this section, had a case when sine was equal to 0, and so that happens at 0 or pi. And then we have down here, when you solve this second equation, you get that the cosine of x is equal to 1/3. Okay, cosine of x is equal to 1/3. Now, this is an interesting problem because we're used to things being equal to 1/2, or the square root of 2/2, or the square root of 3/2, but we haven't dealt with 1/3. Okay, and so it's not one of our special triangles. It's not special on the unit circle kind of thing. And so we need to use our inverse trig knowledge to say that x, so sorry, let me delineate what's going on here because I know I'm writing a lot. Okay. So I have cosine of x equals 1/3. So then I know that x is going to equal inverse cosine of 1/3. Okay, and so inverse cosine of 1/3 is equal to, roughly, when you do it on the calculator, it's equal to 1.231. Okay, 1.231. Now these are all in radians. Okay, so 1.231 is going to be in the first quadrant. So this is our answer in quadrant 1. But we also have a second one. So as usual, when we have these problems, so sine of x equals 0, that happened twice at 0 and pi. There are two places. So there are two answers here. We know that cosine is going to be positive in the first and the fourth quadrants. So we found our first quadrant answer just doing cosine inverse of 1/3. Okay, and that gets us 1.231. But I also need an answer in the fourth quadrant. And so to do that, it's going to have a reference angle of 1.231. And so what I want to do is the other answer. X equals 2 pi minus 1.231. So 1.231 is my reference angle. I know it's not common to see an angle as a decimal, but that, and we're more used to pi's, but it is an it is an angle. And so we want in the fourth quadrant something that has a reference angle of that. And so 2 pi minus 1.231 in decimals is 5.052. 5.052. And so it turns out that the four answers for this problem are 5.052, 1.231, 0, or pi. Okay, and so the important part here is that we didn't, right here, we didn't divide both sides. That would have got us the bottom, these two answers, but we would have missed the top, which is important. So we would have missed half our answers. Okay, so that's the first of the last two identities that or last two problems that we had in 7.1. And so let's go to the last one. Okay, and so this is, well, a lot here. 4 over secant squared of theta plus 3 cosine squared is equal to 2 cotangent times tangent. And I want to solve for all values of theta in our usual domain 0 to 2 pi. And so the thing that we want to do is to try to rewrite the weird things, the weird trig functions, i.e. the ones that aren't sine, cosine, and tangent. We want to rewrite them in terms of sine, cosine, and tangent and see what happens. So the first identity that we want to use on the left-hand side, so right now we have secant squared. Okay, and so we know that we don't actually have to use an identity here, although you could, and it might get some sort of, as they would say, mileage. But the identity that we might want to use is that secant squared is equal to 1 plus excuse me, tangent squared. Okay. Now we're not actually going to use that because what we have on the left-hand side is cosine. And I know there's a relationship between secant and cosine. In fact, I know that cosine of theta is equal to 1 over the secant of theta. Okay. Also, I'm sorry if you hear my dog is in the background snoring. He always does whenever I make a video, and so I'm sorry if that is distracting. But he's doing it, and he loves to snore. So sorry about that. So I want to use this right-hand side one a little more than the left-hand side, because then I'm going to have to deal with tangents and cosines. I'd rather get everything in terms of cosine. So I can rewrite secant squared as 1 over cosine squared. Okay, the squared will stay with whatever trig function that we have. And so I could rewrite this as 4 over 1 over cosine squared, okay, plus 3 cosine of theta. And then on the right-hand side, I have cotangent and tangent. And the identity that I want to use there is that tangent is equal to 1 over cotangent. And so I could rewrite it. I don't want to rewrite cotangent. Rather, I should say the identity I want to use is that cotangent is equal to 1 over tangent. Okay, those two, the previous one I wrote and this one are the same, but I want to use especially this one. Okay, and so on the right-hand side, I have 2 times 1 over tangent times tangent. Okay, and we separate this part here. Okay, when I simplify 1 over cosine, I multiply both the top and the bottom by cosine squared. Okay, and so what I would get is 4 cosine squared plus 3 cosine on the left-hand side. And on the right-hand side, it turns out that these actually do cancel. So unlike unlike the other side where I said we shouldn't cancel, if they are sort of on the same side, or not sort of, if they are on the same side, then we can cancel them, and we get 2 here. And now we have something that we can work with because we got rid of all the cosines. We got rid of all the tangents, and we're only left with cosine. So I would subtract 2 from both sides, and I get 4 cosine squared plus 3 cosine minus 2 is equal to 0. Okay, I could rewrite this. I'm going to. You don't have to. But I'm going to say this is equal to 4x squared plus 3x minus 2. Just so that I'm more comfortable using x's than I am cosines. It's just, I don't know, less clutter. And so I need to, I need to factor something times something equaling 0. Okay, but it turns out it turns out that you can try a number of combinations, so 4 and 1 or 2 and 2 in the front and 1 and 2 in the back, but it turns out that it does not factor nicely. So I gave us a tough-ish problem here because it doesn't factor. And so when things don't factor nicely, unfortunately, you have to use the x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, the quadratic formula. Okay, written more nicely than that. But when we perform the quadratic formula, you get negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 4 times negative 2 all over 2 times 4, which is 8. Okay, and I will skip a few steps and do some mathematical magic. All you do is simplify the things under the square root, and you get negative 3 plus or minus the square root of 41 over 8. Okay, and when you do those calculations for the negative part, you're going to get negative 1.175. And for the positive part, you're going to get 0.425. Okay, so this means these values of x, remember that x is equal to cosine. So over here, either the cosine of theta is equal to negative 1.175 or cosine of theta is equal to 0.425. Now I'm running out of room here, so I'm going to take away this part. But I want to leave our original values down here. Okay, so we found these values of x. Now for the first one, cosine of theta equaling negative 1.175, that turns out to be a problem, and it was the same problem we faced in class. The range of cosine is from negative 1 to 1. And so it's not possible to plug in any value of theta and get a result of negative 1.175. And so, well, we don't have to consider that. And so all we're left with is cosine of theta equaling 0.425. This is like our last example. We need to find, well, where is cosine positive? Cosine's positive in 1 and in 4. So we need to find two values of theta that give us 0.425. And so theta is equal to the inverse cosine of 0.425. And that, when you put that into the calculator, you get 1.131. Now, when you put those things into the calculator, it gives you one answer out, and so you might be wondering, why do we get eventually two answers? Well, remember that the domain of cosine inverse is the range of cosine inverse and sine inverse and tangent are restricted to ranges so that the function is 1 to 1, so we can take inverses, all the weird stuff that we sort of talked about before. But basically, it's only going to give us one solution, probably in the first quadrant. Okay, for cosine, maybe in the second quadrant as well, but probably in the first one, and then we need to find that second one. And so we're going to do the same thing. I want to find That's 1.131. That's in the first quadrant. We need to find the one in the fourth quadrant. So we do the same thing as we did last time. It has a reference angle of 1.131 now, and so that's 2 pi minus 1.131. And when you do that, you get 5.152. And so it turns out that we couldn't consider this cosine e being equal to negative 1.175, but we were able to consider the other one. And so the two possible answers for theta are 1.131 and 5.152. Okay, and so that mercifully ends section 7.1 using identities to solve trig equations.